Okay, so here we have an example of where set operations can get pretty difficult. The problem reads like this. There are 30 students surveyed yielding the following data. 20 of them like Captain Morgan, 8 like Keystone Light, 10 like Miller, 6 like neither Captain or Keystone, 5 don't like any of these drinks, and 0 like both Keystone and Miller. Okay, so I went ahead and drawn the universal set and the Venn diagram with the subsets representing C representing Captain, K representing Keystone, and M representing those students that like Miller. And I already have a little 1 drawn in here, which I really shouldn't, so I'm just going to take that away. Anyway, and I have a 5 out here too, which that 5 that I have drawn in represents those students that don't like any of these drinks. Obviously, if they don't fit with any of these sets, they're obviously outside of these sets, so they're going to be represented out here, just in the space of the universal set, but not within any of these subsets. Okay, and then we have the number of elements in the universal set is 30. We know that 30 students were surveyed, which is an important number. And we're trying to find how many students surveyed like both Captain and exactly one of the 2 types of beer. So we're not trying to find the students that like both beers. We're trying to find the number of students who like Captain and just one other type of beer, whether that be Keystone or Miller, but not both at the same time. So basically, we're trying to find these 2 areas here, and we're trying to add those together. Okay, so first off, in these problems, if you've worked these problems before, you should know that you're always going to want to start in the middle so you don't count anything twice. And for this problem, it really doesn't give us the middle. The middle would be like, you know, X amount of students like Captain, Keystone, and Miller, or 0 students like Captain, Keystone, and Miller. It doesn't give us the middle right away, but it does tell us actually that 0 like both Keystone and Miller. And if 0 like both Keystone and Miller, we know that there can't be any students who like all 3 of these, because that just wouldn't make sense. If 0 of them like both Keystone and Miller, you can't have, you know, like some 4 of them liking all 3. So obviously 0 is going to go right there. None of these students like all 3 of these drinks. Okay. And we already have assigned that 5, and I already explained that. 5 don't like any. I feel like that's pretty obvious. Most people can get that. And then 6 like neither Captain or Keystone. Okay, so, but keep in mind, some of these 6 don't like any of these drinks, and that's this 5 out here. So we know that if 6 like neither Captain or Keystone, but 5 don't like any, that just leaves 1 that likes just Miller, because if they don't like Captain or Keystone, they must either like Miller or none of these, and we know that 5 like none, so that just leaves 1 of those 6 left to like only Miller. Okay, so that's how we got that. Now we can move up through our problem. We know that there's 10 total that like Miller, 0 that like Miller and Keystone, so we know that there must be 9 left out of those 10 that like Captain and Miller. So we've completely partitioned those students who like Miller. 9 who like Captain and Miller, 1 that just likes only Miller, and 0 that like Keystone and Miller. Okay, so we can move on. There are 8 that like Keystone. Okay, well the problem is we don't know what this is. We don't know the amount of students that like both Keystone and Captain, and by looking at the rest of the problem we can tell that that's not really directly given away. So right now I'm just going to assign a variable to the intersection of K and C here, and I'm going to make that variable X, just because that's a pretty universal variable. So we know that 8 students like Keystone, but we don't know how many like Keystone and Captain, so we don't want to count this number twice, so we'll put 8 minus x, because you don't want to count the intersection of k and c twice. So obviously I've assigned the intersection of k and c to x, and we know that this number out here will be whatever the number of students like Keystone minus the number of students like both Keystone and Captain. Okay, so we can go up here and do the same thing for Captain. We know that there are 20 students who like Captain. We know that 9 of those students also like Miller, that like Captain and Miller, so we don't want to count those students twice, so that leaves 11, but it's also 11 minus x, because we still don't know what this is, and again, you don't want to count the intersection twice. So now we can solve for x, and how we're going to do that is like this. Well, first of all, now that we've kind of defined every value here for each of these different partitions, we know that it has to total up to 30, and we know that, well, there's 9 here, 1 here, and 5 here of just definite values that we have, so that totals up to 15, and there's 0 here, so we know that there must be obviously 15 left in here, because these are the only spaces left that haven't been, defined by a real value of it, or a real valuable number. So we can just basically make these 3 things here all equal to 15. So we'll do it like this. We'll probably do it down here, this will be better. Draw a line here. Okay, 15 equals 11 minus x plus 8 minus x, and we can just simplify that to 19 minus x. 15 equals 19 minus x, and then we can just we could add x to this side, and that would give us x plus 15 equals 19, and then we could just subtract 15, and that will give us x equals 4. So then we've solved for x, so we know that if this is now 4, I'll go ahead and erase that and make it x is equal to 4. Well, we know that 8 minus 4 is going to equal 4, and then 11 minus 4 is going to equal 7. So then that gives us, really, I mean, I didn't even have to solve these areas right here, because really what we're looking for is just, as I highlighted earlier on when we started this whole problem, we're looking for those students that like Captain and exactly one of the 2 types of beers. So we have that here now. We have this here. So instead of plugging x in there, I could have just stopped once I figured out x was 4 and just added these 2 together, added these 2 values together, and gotten 13. And that's our answer. There's 13 students who like Captain Morgan and exactly one of the 2 types of beer. And that's your answer.